you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, Mr. T here with a Trig tutorial. Today we're going to be starting a series of tutorials on solving trig equations. I'm going to break it up into a couple parts. As we go through each part, the complexity of the equations will increase. Today we're going to start fairly simple. So let's get started. So first, we'll quickly review solving a trig expression like this where there's a single trig function and it's by itself. Now there's an earlier tutorial that goes through this in much more detail that you can watch. I'm just going to hit the highlights here. If you remember, we have our unit circle, and when we use the unit circle, remember the y coordinate is the sine value of an angle. The x coordinate is the cosine. And if we need to find the tangent, we have to use y over x. So we would have to divide the y's and the x's for each point to find out what its tangent value is. Now, we will be restricting our solutions in the interval of 0 to 2 pi, meaning within one revolution of a circle. Remember, trig functions are periodic and the angles can keep going forever. So there are an infinite number of solutions to this problem, but when we restrict it to this interval, there will be a finite number. So to solve this equation, sine of x equals negative square root of 3 over 2, we can translate that given the information we have over here as we want to find all the places one time around the unit circle where the y coordinate equals negative square root of 3 over 2. So if we start here at 0, its y coordinate is 0, and we scan around till we find a negative square root of 3 over 2. Now here we have square root of 3 over 2 here, but it's positive, so we keep going. Positive. So we get here. So that angle is 7 pi over 6, so one of our solutions is 7 pi over 6. And we keep going till we find to see if there's another, whoops, I made a mistake here. As you can see, this is the x coordinate, so that is not one of the answers. Let's get rid of that. So here we have the y coordinate, so 4 pi over 3. And keep going, and here we have another one here, 5 pi over 3. And now we're up to 2 pi, so we stop. So we only have two solutions for this one. Now this works when our trig functions have the special values, the exact values that we had learned for these special angles. Now it's possible that this is not one of the special angles. So on these we're going to have to use our calculator to find approximate solutions. So remember, we can, to solve a trig value here to find the missing angle, we need to calculate the inverse sine of that number. Now since our interval here was 0 to 2 pi, we want to make sure our calculator is in the radian mode, because we're looking for radian answers here. And when we're looking for answers, remember 2 pi is approximately 6.28, so we'll be looking for answers between 0 and 6.28. So let's calculate here. Let's do the sine inverse of negative 0.3. Now we get an answer here, but this answer is not in our interval. A negative number is not in this interval here. So let's draw just a little sketch. So this is our angle in radians, so negative 0.3. So if we did in radians, this is 0, This is pi over 2, which is about 1.57. This is 1 pi, so 3.14. And this would be 3 pi over 2, which is about 4.71. And then we get around here where it's 6.28. So if we go negative 0.3 radians, we're down here somewhere. Now, if you remember, we have a thing called a reference angle. So this is our reference angle. So our reference angle is, now we did this in degrees the first time we went around, but we can do the same thing in radians. So our reference angle is 0.3 radians. Now, we're looking for places where the reference angle is 0.3, but in the right interval. So the sine, remember, sine is the y-coordinate, so the sine is positive here, it's positive here, it's negative and negative. So we're looking for a quadrant 3 solution and a quadrant 4 solution. So if we look in quadrant 3, that would be here. Again, this is 0.3. So we would be, our x value is a little bit more than 3.14, so it would be 3.14 plus 0.3, or let's call it 3.44. And now we need, here we have negative 0.3. So we could take 6.28 in our Q4 minus 0.3. So our x value here is about 5.98. So we have to use our reference angles here because we're going to be finding more than one solution. Depending on the trig value, when we do inverse trig, the domain of that function is different. The sine will return you angles in this range from positive pi over 2 to negative pi over 2. Cosine gives you angles between 0 and pi. And the tangent gives you angles between negative pi over 2 and pi over 2. So we have to make adjustments. We'll be working a tangent problem later in the video. Again, if you need more explanation than I gave here about using reference angles, there's a whole video that talks about using the reference angles. Now, our next problem is a little bit more complicated because we don't just have sine of x equals a number. Now, we're going to go through in the series a whole bunch of functions where we're going to be using a combination of algebra and basic trig identities to simplify these expressions to be able to solve them. Now, in this case, we have a sine on both sides, so we want to combine like terms, so we can add the sine of x on both sides of the equation. So we get 2 sine of x plus square root of 2 equals 0. And now we want to get the sine of x by itself, so I have to subtract the square root of 2. And then I'm going to divide by 2. So we've got sine of x equals negative square root of 2 over 2. Now this is one of the numbers that we get when we have an exact angle, so we can use our unit circle like we did last time. Again, I use the sine function here, so we're looking for y values. So let's go around the unit circle and look for y's that are negative square root of 2. Now we know we're going to be over here in the third and fourth quadrant where y's are negative. So here we have an angle here, so one solution is 5 pi over 4. And we have this solution here, which has the y value of negative, so we have 7 pi over 4. Now let's repeat this same problem where we do not have one of the special angles. So we're going to do the same steps to solve. We're going to add the sine over here. And we'll move this to the other side. So we get 0.3. We'll divide by 2. And we get sine of x. Whoops, what am I writing there? sine of x equals, and if we divide this out, we get 0.15. So we have to use the calculator this time. Now, since this is positive, we're going to be looking for solutions in Q1 because the y is positive in quadrant 1, and we'll be looking in quadrant 2 because the y's are positive here. We need to figure out our reference angle first, so let's bring our calculator in. And now we want to look at, again, we're going to get the reference angle here. We're going to be taking the inverse sine of 0.15. And we get 0.15. Now that just happened to come out that way. I just picked this and I guess got lucky that the two numbers were about the same. Now 0.15 radians is in the first quadrant. So that is our first quadrant solution. And now we need a second quadrant solution that has a reference angle of 0.15. So remember, over to here is 1 pi, which is about 3.14. So for our second quadrant solution, we want to take 3.14 minus 0.15, which would be approximately 2.99. So here we have our two solutions. All right, let's look at a different function. Let's look at the tangent function and also a different type of equation. Now this time we have a single trig function in here, which makes it easier, but we have a squared. So when we solve a quadratic equation with a single x squared, remember we can use square roots. So we would add the 1, get the x squared by itself, and then we would take the square root of both sides. And an important part is we have to remember that we have both a positive and a negative square root. And then we could rationalize that. So if we do the same thing over here, we've got 3 tan squared of x equals 1. We divide by our 3. We square root both sides, so when we square root tan squared, we get tan of x. And over here, remember, we've got to put our plus or minus square root of 1/3, which is plus or minus 1 over square root of 3. And we want to rationalize. So we need to solve the equation tan of x equals plus or minus square root of 3 over 3. Now in this particular case, this is one of the exact tan values. Now remember, to find tan values, we have to take y over x. So if we look at this one, say pi over 6, I've got to take 1/2 divided by square root of 3 over 2. So let's give ourselves a little room. So we're taking y divided by square root of 3 over 2. That becomes, we have a complex fraction. We're multiplying by the reciprocal. So we're going to multiply by 2 over square root of 3. Our 2's cancel out. So we get 1 over radical 3, which is the same thing we had here. So this is going to be the answer. So we get square root of 3 over 3. So this is one of the solutions. So this is positive square root of 3 over 3. If we come over here to have the same two numbers, the 1/2, so this would, and then we have a positive and a negative, so this is negative square root of 3 over 3 for the tan. Here we have a 1/2 into this. This would be positive square root of 3 over 3. And come over here, we've got negative square root of 3 over 3. Now remember, we're looking for both positive and negative solutions. So we're going to have, in this case, 4 solutions. So we've got this angle here, pi over 6. We've got this angle here, 5 pi over 6. here, 7 pi over 6. And finally here, 11 pi over 6. Now if you forget this plus or minus symbol, we would only be looking for positive square root of 3 over 3, and we would have only listed those two solutions, and we would have missed half the solution. So it's very important that you remember this plus or minus. Now let's look at our final problem. We're going to be doing the same thing as we did, but this time it's not going to come out to be a perfect square. So we get tan squared. If I add 1 and divide by 5, we get 1/5, which is 0.2. Square root both sides. So we're looking for plus or minus say that's 0.447. So we need to, so this is now the tan of x because I took the square root. So this here should not have had the square root because we took the square root. So that square root symbol is missing. So now we've got to look at tan of x, or tan inverse, sorry. So our x will be tan inverse of positive 0.447 and tan inverse of negative 0.447. Now, we can see here on the positive and negative tans that we had the same reference angle. So we really, to get the reference angle, need to find one solution here. So I'm just going to do this one. So my reference angle is 0.42. So we need to find solutions where the tan is both positive and negative. So we need essentially solutions in all four quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Whoops. Sorry, I'm having trouble writing that as a Quadrant 4. So Quadrant 1 is going to be the 0.42. Quadrant 2 will be this angle where this is 0.42. So we need to take 180, pi, which is 3.14, minus 0.42. Q3 will be this angle, so we're taking 3.14 plus 0.42. And quadrant 4 here will be 2 pi, which is 6.28, minus 0.42. So if we summarize those answers, we had 0.42 radians. Here we're going to get 2.72 radians. Here we get 3.56 radians. And out here we get 5.86 radians. That's an 8. And those are our four solutions. So we've reviewed solving basic trig functions using exact values when we have the special angles, and using the inverse trig function and reference angles when they are not exact values. And we reviewed two skills in this video: combining like terms. So in solving these problems, we did combining the like terms. And in our tangent problem, we took square roots of both sides, remembering both the positive and negative. So good luck, and I'll be talking to you soon with part 2 of solving trig equations.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you